By the end of this lesson, you should be able to identify the location of the key components in an atom, which are the protons, the electrons, the neutrons, the nucleus, and the electron shells. And you should be able to identify the properties of the three subatomic particles, which are the protons, the electrons, and the neutrons. Before we dive into this lesson, you'll want to create a table like the one on the screen in your notes. So go ahead, put this video on pause. When you're done creating this table, come back and push play. First, let's discuss two key locations. The first location is the center. This is what we call the nucleus. This is this blue area. It's the center of an atom. Then on the outside, we see these green circles. These are what we call the electron shells or the orbitals. So there are two key locations, the electron shells or the orbitals, which are on the outside, and the nucleus, which is the center. Keep in mind when we talk about electron shells, you could have one circle, you could have two, you could have three, you could have four, or more. And we'll talk about how you know how many to have in a future lesson. Then there's the three subatomic particles, the electrons, the protons, and the neutrons. The electrons are found on the electron shells. They're found on these green circles. Then in the middle, in the nucleus, this is where you find the protons and neutrons. There are other models out there of the atom. So here on the left, we have a model. It looks slightly different, but in the middle is the nucleus, and this is where the protons and neutrons are found. Then on the outside, we have our electron shells, and these black circles are our electrons. They're on the electron shells. Or over here, we have the electron shells, these circles, and these little blue dots, they are my electrons. Then in the center, we have our protons and neutrons. In your table, you should now have the location of the three subatomic particles. So the protons are in the nucleus, the electrons are on the orbitals or on the electron shells, and the neutrons are located in the nucleus as well. Next, we're going to look at a PhET simulation, which we have up on the screen. In the middle here, you see this yellow X. This is the nucleus. Then on the outside, these blue dashes, each circle represents an electron shell or an orbital. So let's look here. If I add a proton and a neutron, they go in the center. And then if I add my electron goes on the electron shell. But what I want to focus on is this net charge. So pay close attention to this net charge. When I add a proton, I see it goes to +1. If I add another proton, it goes to +2. Each proton represents a +1 charge. So each proton is +1. Now, let's go back to our original setup. And let's add a neutron and see what happens to the net charge. It stays 0. Stays 0. So that means a neutron has no charge. It has a net charge of 0. So let's go back to the original setup and let's add some additional electrons and see what happens to the net charge. So add an electron, it goes to -1. Let's add another electron, -2. Each one of these electrons is a -1, meaning it has a -1 charge. If you would like to work with this simulation a little bit, you can go to the following link. Once you're there, you'll click on the atom, and the following simulation will appear. In your table, you should now have the charges of each one of the subatomic particles. So protons have a +1 charge, electrons have a -1 charge, and neutrons have no charge, so a charge of 0. At this point, we now know the location and the charge of each of these subatomic particles. Now, I want to identify the symbols of each of these subatomic particles. To do this, we need to know the first letter in each one of the names, so P, E, and N, and we need to know each of the charges. So when we talk about the symbol of the subatomic particles, the first letter needs to be lowercase. And then when we talk about the charges, we only need to include the plus, the minus, and the 0. So you don't need the 1 in front here. So let's talk about the symbol for a proton. I need the first letter of the name in lowercase, and I need the charge. So first, let's look at the first letter. It's a P, so let's write it lowercase. Okay, P. I know it has a +1 charge, so it has this plus, and I'm going to write that as a superscript. So here is my symbol for a proton, lowercase p with a plus. Now what I want you to do is predict the symbol for a neutron. Put this video on pause, predict the symbol for a neutron, then come back and push play. Okay, so the neutron, we have to take the first letter, that's N. So let's write N lowercase. I know a neutron has no charge. The charge is 0. So I put a 0 as the superscript. And there is my symbol. Lowercase n with a 0 as my superscript. Now I want to do the exact same thing but for an electron. Put this video on pause, predict the symbol for an electron, then come back and push play. All right, let's take a look at the symbol for an electron. The first letter of electron is E, so let's write a lowercase e. And I know an electron has a -1 charge, so I have this minus symbol, and I put that as my superscript. And my symbol for an electron is E minus. Now in your table, you should now have the symbols. So the symbol for a proton is P plus, the symbol for an electron is E minus, and the symbol for a neutron is N0. Now you have the location, the charge, and the symbol. Next we need to talk about the relative mass and the actual mass. So first, let's look at the relative mass when we talk about the neutron, the proton, and the electron. The neutron and the proton have a much larger mass than the electron. In fact, the neutron is slightly larger when we compare the masses compared to the proton. But in general, we say the proton and the neutron have a relative mass of 1, where the electron is much, much, much smaller. Well, the proton, neutron, and electron also has an actual mass. The proton and neutron, although they're slightly different in regards to the mass, we say that they have the same mass of 1.67 times 10 to the negative 24 grams. But what we see here is the electron has a mass of 9.11 times 10 to the negative 28. That means this decimal gets moved over an additional 4 times to the left, which makes it much smaller. So let's say somebody offers you $1 million or $1,000. There's a big difference. You'd probably take the million. Just like here, there's a big difference between how many decimal places this decimal moves to the left. The more it moves, the smaller the number. So keep in mind the electron is much smaller when we compare the mass. So in your notes, you should now have the location, the charge, the symbol, the relative mass, and the actual mass. If there is something missing from your notes, put this video on pause right now, get it into your notes, and then come back and push play. The other thing you should have in your notes is the location of the nucleus and the electron shells or orbitals. So the nucleus is the center part of an atom, and the electron shells and the orbitals are on the outside. They're these green circles. If you don't have this in your notes, put this video on pause, get this in your notes, and come back and push play. What we're going to do is do a little practice. For each question that's going to pop up on the board, you'll want to put the video on pause as soon as the question pops up. Then you want to give the question a try. When you're done and you have the question answered to the best of your ability, come back and push play so you can hear the answer and the explanation. Here's the first question. So go ahead, put the video on pause. When you're done answering the question, come back and push play. Question 1, what subatomic particles are found in the nucleus? Choose all that apply. There are 2. The neutrons and the protons are found in the nucleus. That's the center part. That's the center here. Question 2, put the video on pause, give the question a try, and then come back and push play. Question 2. What subatomic particles are found in the electron shells? Choose all that apply. These are the electrons. The electron shells are the circles on the outside, and the electrons are found on the electron shells or the orbitals. These are the blue dots here. Question 3. Put the video on pause, give this question a try, and then come back and push play. Question 3. What are the symbols for a proton, an electron, and a neutron? And the answers are the following. Protons have a P plus for their symbol. P is the first letter of proton, lowercase, and the plus represents the charge, so the plus. The electron, the first letter is an E, make sure that's lowercase, and we have a charge of -1, so we just take that minus and plop it there. Then you have the neutrons, the first letter is an N, so we make sure that's lowercase and the charge is 0.